Hi, welcome to the video on problems based on parallel resonance. In this video, we are going to see two problems based on RLC parallel circuit. So now let us see problem 1. The question is given as the RLC parallel circuit shown in figure 1. So this is figure 1 where R, L and C all are in parallel, which has got an input voltage source, which is an AC input voltage source, value given as 10 sin omega t. The value given in the question for the resistance is 8 kilo ohm, for the inductance is 0.2 millihenry, for the capacitance is 8 microfarad. Now in the question they are asking you to find out the resonant frequency, quality factor, bandwidth and cutoff frequencies. So when you start the solution, just write the given data. We know the resistance, inductance and capacitance value, and we also know the formula for calculating the resonant frequency in radians per second. So omega R is equal to 1 by root of LC. Just substitute the values of L and C. We get the answer as 25,000 radians per second. Next, we are going to find quality factor at resonance. So QR, we know the formula as omega R into C into R. So if you substitute all the values here, you get the quality factor at resonance as 1600. Next, bandwidth. We know the beta relation as omega R by QR. So if you substitute the values there, you get the answer of beta as 15.625 radians per second. And by derivation, you would have got the answers of omega H and omega L of a parallel resonance. Just by using that formula in terms of quality factor, we can substitute the values here and get the answer of higher cutoff frequency omega H as 25007.8 radians per second, and the lower cutoff frequency omega L in terms of quality factor formula. If you substitute, you get the answer as 24992.2 radians per second. So all the answers which we have got here is in terms of radians per second. Okay, so by using just the formulas, we get the answers of resonant frequency, quality factor, bandwidth and cutoff frequencies. Now let us move to the problem 2, which is also of the same type. Here in problem 2, the question given is the parameters of an RLC parallel circuit excited by a current source. So they have given you the R, L and C values. Determine the resonant frequency, quality factor, bandwidth and cutoff frequencies. So the formula will be slightly different because it's excited by a current source here. The previous problem which we saw was excited by a voltage source. So now let us see what are the formulas. So angular resonant frequency is going to be the same formula. Omega R is equal to 1 by root of LC. So just substitute the values, you get the value of omega R as 12910 radians per second. If you want to get the same resonant frequency in terms of hertz, just divide it by 2 pi. So FR is equal to 2.0547 kilohertz. Now quality factor at resonance for excited by current source. So that QR formula is R by omega R into L. So remember this correct formula, and if you substitute, you get the answer is 1.5492, and the bandwidth relation for this kind of current source excitation is given as 1 by RC. So if you substitute the value, you get 8333 radians per second. And if you want this bandwidth beta in terms of hertz, just divide it by 2 pi, you get the answer as 1326.3 hertz. Okay, but if you want the same thing in terms of kilohertz, you can just divide it by 1000. So you get 1.3263 kilohertz. Okay, so cutoff frequencies also, you have got two cutoff frequency. One is higher cutoff frequency, other one is lower cutoff frequency. FH. So the formula in terms of quality factor is written. So just substitute the values there. You get the answer as 2.8222 kilohertz. And FL, that is lower cutoff frequency also, just substitute in the correct formula, where the only difference in these two formulas a minus sign here. Okay, so if you substitute the correct values, you just get the final answer of FL as 1.4959 kilohertz. So all the parameters which is asked in the question is been derived, or the right answers have been got by using the correct formulas. I hope by watching this video you would have clearly understood the problems based on parallel resonance. Thanks for watching.